Hello, so this video is going to be about a mathematician called Pythagoras who allegedly drowned one of his students and one of his theorems that he came up with. It's all about right-angled triangles. So let's have a look at what you need to be comfortable with in order to answer these sorts of questions. So you need to be able to use powers. So, for example, 3 to the power of 2, 3 squared. You also need to be able to do square roots of numbers. So, for example, the square root of 25, which is 5. Rounding to a given number of decimal places is important as well. So, first thing you need to know is Pythagoras will only ever work with a triangle that has a right angle in it. So we know that all triangles, the angles in all triangles have to add up to 180, but Pythagoras will only work if one of those three angles is 90 degrees. Now the red sides in all of these triangles on the screen here have a right angle in them. The red side is what we call the hypotenuse, and this is really important because the hypotenuse is always the longest side of a right-angled triangle, and that longest side, that hypotenuse, is always directly opposite that 90-degree angle. It doesn't matter what way round the triangle is. When I've got my right angles in my triangle, the side that's not attached to that right angle, the side opposite that right angle, will be the hypotenuse, and that will be the longest side of a triangle. That is really important with all of your work on Pythagoras. Okay, so what Pythagoras allows you to do is, in a right-angled triangle, if you are given two of the sides, you can use Pythagoras to work out the length of the third side. Now, you need to know this formula here: c squared equals a squared plus b squared. Now, it looks complicated, and in words it means the square of the hypotenuse is equal to the sum of the squares of the other two sides, which also sounds complicated. However, what we're going to do is, the first thing you're going to do with this formula is you're going to label the sides of the triangle. Now, the A and the B, it doesn't matter which way round they go, but I suggest you always start with the C, and that C, it has to be the hypotenuse. So we're going to label the sides A, B and C. Now remember, I said that wherever the right angle is, the side opposite that, that's not attached to that right angle, is the hypotenuse. So we are going to label this side C. Now it doesn't matter which way round the other two sides go, but we could do the 6.5 as A and the 7.8 as B, but you could equally do the A and B the other way round. Okay, now all we're going to do is we're going to substitute these values into this formula over here. So C, instead of C, we're going to use x squared is equal to whatever a squared is. So a is 6.5, so we're going to write 6.5 squared there, and then we're going to write we're going to add to that whatever b squared is. Now b is 7.8, so we're going to do 7.8 squared. Okay, now what I suggest you do is, remembering your rules of BIDMAS or BODMAS, you have to do the powers before you do any adding. So I'm going to write x squared. I'm going to leave that as x squared for a second. And in my calculator, I'm just going to work out what 6.5 squared is. And that comes out as 42.25. And we're going to add to that whatever 7.8 squared is. So 7.8 squared gives you 60.84. 60.84. Okay, and now we can add these two things together. So I know that x squared is equal to 42.25 add 60.84, which comes out as 103.09. Okay, so as soon as you've done that, we know that x, whatever x is, that's what we're trying to find. If I have squared that number, I get 103.09. So to undo that squaring, we want to do the inverse of squaring a number, which is to square root a number as well. So when I square root x squared, I get x, remembering whatever I do to one side of the equation, I have to do to the other. And then all I'm going to do is square root that 103.09, and to one decimal place, that gives me 10.2, not 10.1. And then don't forget the units. Everything over here was in kilometers, and that was to 1 decimal place. So that's it. That's your answer. That's the first example. I've got 3 more which we'll work through now. So remember I said this tends to catch people out. Remember I said that the triangle can be kind of rotated any way, and these tend to catch people out. You still need to start by seeing where the right angle is, and then saying that this side here is the hypotenuse. So when I label it using my formula c squared equals a squared plus b squared, this has to be c, the hypotenuse has to be c, and then it doesn't matter which way round the a's and the b's go. So I'm just going to say the 14 is the a and the x is the b. Now when I substitute those values in, you want to be careful here. C squared, that's my hypotenuse, so that's 16.8 squared, is equal to a squared, well that's 14 squared, plus b squared, which we're going to use x instead, squared. Now, this is where people go wrong. In the last example, we were finding the hypotenuse. We didn't know what that was, and we had to work out what that was. In this example, you have been given the hypotenuse, and you're trying to find one of the 2 shorter sides. So straight away, you can think if you get an answer that is bigger than 16.8, you know that you have gone wrong, because remember I said the hypotenuse has to be the longest side. So we're just going to bear that in mind. If I do 16.8 squared, I get 282.24, and then 14 squared is 196 plus x squared. Okay, so I want to end up with x squared equals something, because then I can work out what x equals. So the thing that is stopping me from having just the x squared over on the right hand side of the equation is this 196. So there's an invisible positive there. I want to do the inverse. I want to get rid of that. So to get rid of positive 196, I need to take away 196 from both sides of the equation. So 282.24 take away 196 is going to give me 86.24, and that is equal to x squared. That is the same, 86.24 is the same, equals x squared, is the same as x squared equals 86.24. So it doesn't matter which way round you write it. So now what I'm going to do is I know that x squared, whatever I'm trying to find, squared, is equal to 86.24. So to undo that squaring, I need to square root both sides of the equation. And if I do that, I'm going to get x equals 9.3, remember units, centimetres, that's to 1 decimal place. It's always worth checking at the end whether or not that looks reasonable. So 9.3 centimetres, remember it cannot be longer than the hypotenuse, and if this length, the hypotenuse represents 16.8 and this length represents 14, it seems realistic to me that that could be 9.3 centimetres, this length here. Okay, that's the first 2 questions. The next one is quite a common kind of exam question. You are given all 3 lengths and you're asked to figure out if it is a right angle triangle. So the way you would approach this question is to remember that Pythagoras will only work if it is a right angle triangle. If it's not a right angle triangle, Pythagoras will not work. So if this were to be a right angle triangle, this would be the 8.8 centimetres, this point here, this line here, sorry, this side would be the hypotenuse because it is the longest side. Therefore, this would be the right angle. Just because a triangle looks like it might have a right angle, it doesn't mean that it necessarily does. You might get something written like this, not drawn to scale. So if this were a right angle triangle, the right angle would be there because that is opposite the longest side. So all I'm going to do now is I'm going to use Pythagoras' theorem, the formula, and we're going to see if that works, because if that works, this has a right angle triangle. If it doesn't work, it does not have a right angle triangle. So c squared equals a squared plus b squared. C has to be the longest side, so there's C, and I'm going to say that's A and that's B. So c squared would be 8.8 squared equals A is 4.5 squared and B is 6.6, so we need to square those as well. So now I'm just going to work out what 8.8 squared is. That's 77.44 is equal to 4.5 squared is 20.25, and then 6.6 squared gives me 43.56. So now I'm just going to see if this works. So 8.8 squared was 77.44. I'm just going to add these two on the right hand side now. So 20.25 add 43.56. That gives me 63.81. So you can see that 77.44 actually does not equal 63.81. Because it does not equal 63.81, therefore this is, you must remember to actually answer the question, is it a right angle triangle? No, because 77.44 does not equal 63.81. That's it. So you're just going to see if Pythagoras works. If the left hand side did equal the right hand side, that means it does have a right angle. It is a right angle triangle. Okay, last example. So you might in an exam get a question on Pythagoras that's not straight away obvious that it is a question on Pythagoras. Sometimes the topic is hidden within the question. This is an example of where that might happen. So the first thing, looking at this triangle, is that the triangle you're given is not a right angle triangle. These two lines here means that those two sides are the same, and therefore this is an isosceles triangle. Because it is an isosceles triangle, if I were to put a line straight down the middle, that actually cuts this triangle exactly in half. So if I just draw out this part of the triangle, this length here, sorry, if I cut the triangle in half, it makes a right angle because this height is what we call perpendicular to the base of the triangle. When it does that, this splits the base of this big triangle in two. So this length here is just going to be 19.6 divided by 2. This only works because it is an isosceles triangle. So this length here is actually 9.8 millimeters, just 19.6 divided by 2. In fact, let's write that down. Gives you 9.8 millimeters. Because the whole triangle in the question is an isosceles triangle, this length and this length are exactly the same. Therefore, this is 12.3 millimeters. We are asked to find the height. Now this height here, this length here, is going to be the same as this length here. So we're actually being asked to find what this length here is. Now this is one of those questions. Now we have a right angled triangle and we have two of the three lengths. We can find the third length. In this case, the height, the perpendicular height of the triangle. So we're just going to label. We're going to write out c squared equals a squared plus b squared. Label my sides C and then A and B. Now I'm just going to substitute those values in. 12.3 squared is equal to 9.8 squared plus x squared. So now just plugging these values in, 9.3 squared gives me 151.29. is equal to 9.8 squared, 96.04, plus, I don't know what x squared is yet. So what's stopping me from just having x squared on one hand, what on the right hand side of the equation? That's this bit here. So I want to take away 96.04, and I have to do that to both sides of the equation. So I'm doing 151.29, take away 96.04, and that gives me 55.25 is equal to x squared. Remember, if it's easier for you, you can swap those two things around, so x squared equals 55.25. Now we want to undo squaring the number, so I'm left with x equals. So squaring a number, square root both sides. So I'm doing the square root of 55.25, and to one decimal place, that gives me 7.4, always check what the units were. In this case, it was meters. So that is my answer. The height of this triangle is 7.4 millimeters, and therefore x over here was 7.4 millimeters. Okay, that's it. That's all four examples. Very quickly, I'm just going to show you this spreadsheet that I've made. So, increasingly difficult questions. Oh, remember when you open it, there'll be a yellow band ribbon thing that appears at the top. You must click Enable Content, otherwise the buttons won't work. So, all right, lots of questions of increasing difficulty. And you can get the answers one at a time, or you can get them all at once. If you want to try a particular type of question, you just generate type 1, type 2, type 3, type 4. And when you've got the hang with all of them, you can try a mixture of them where I don't tell you what kind of question it is, and that will just help you practice and kind of develop some confidence with Pythagoras and using his theorem. That's it. I hope that's been useful. Thanks very much for watching. Bye-bye.